So in the last video, we talked about variation, right? So you're repeating the process over and over again. You're measuring something from that process, okay? And then in some cases, you can be totally off target, right? So your variation was okay. It was very precise. The dots were, in a specific spot, but it was the wrong target, right? You don't want it to be there. You want it to be a little bit to the left, or a little bit to the right. In another example, we weren't exactly center where we're supposed to be throwing our darts, but the variation was too high, right? And that comes from getting a sample. Okay, so you're getting a sample of your process by repeating the process, collecting some data, and you look at those and try to understand what variation is occurring and if you're center or too much or too less, right? So we saw that with the target. Now we're going to see with some charts. But keep in mind that we also want to know if that it's only happening normal cause variation, which is the one that we expect to happen, right? Or if it's a special cause variation that's happening, right? Or if it's too much and was not supposed to be, too far away, and the special cause is happening because of a special thing that, or something that you can highlight on the process, right? So I'm throwing my darts, and for no reason the darts are going too much to the right or to the left. I'm doing a very bad job. And someone have to look at that and say, I think something's going on with Dr. Morodin, and then goes and try to find out why I'm doing a bad job. And that could be because I only slept 2 hours that night, or it could be because my team lost the game last night, or, whatever problems you guys have in your lives, right? So here we come to discuss these different distributions, right? And when you talk about distribution, we talk about variation, we talk about target, we talk about sample, right? What does that mean? Some red light should be blinking in your brain right now, saying, if he's talking about all those terms, he's probably going to get into statistics. Yes, I know you're very excited about statistics. You have all those good memories of stats and 290s and all that, 291s and all that, right? So, what is that from your stats class and nightmares with stats class? This is a normal curve distribution, right? Or a bell-shaped curve, right? And what does it represent? That's a histogram something that we collected data from. We went there and we collected data from 100 tacos, how long it takes, what was the quality of those. Or I can take your height, for example, right? And then I take the height of my 60 students. We have most of them that are going to be, and divided by gender, because that could be also impact on the results. So let's say I only take women here. I have an average, middle point. A lot of people, or most of the people, are going to be around the mean, right? And they're going to have some very short people, but very few. And they're going to have some very tall people, but very few of them, right? So that's a histogram, and here I have the height, right? And the height of the bars is how many people go and fit into that description, right? Same thing, we're going to take a sample of anything. We're collecting time, we're collecting height or weight, or distance or durability, or whatever thing we're measuring in terms of quality of the product. And let's say that we collect it, okay? And we expect that distribution to be the green one. But what actually happened was that it ended up being the red one. So what's going on? What is the problem here? So hopefully you said that there's a problem with the mean, right? So you can see that the variation is as expected, but the average, or the mean, was higher than expected, right? So let's say that I take a distribution at the height of women, and then I say, okay, this is what I expect to be the distribution of the height of that population, right? But then you take a sample of the height of men. So what we expect, well, some variation will occur, but I expect, what will happen is the average will be higher, right? So higher than I expected before. What's going on? So the problem with location, the average is different, right? What happened with the second one? Hopefully, you're saying that the average is the same, and I have a difference on the variation. What does that mean? Well, it means that is mean center here, the average is the same, but the variation is higher. So if you go back to, to this, right, I have this example here is a problem with spread, right? So I'm mean center here, I'm aiming for the target, but my variation was too high, okay? In this case, my variation was small, was as expected, but it was outside. So that's the location problem, right? The mean was higher than it's supposed to be, okay? What is going to be the last one? Well, I know that you guys know how to read, so you know that's a problem with the shape, right? So in this case, it is a right skewed distribution here. So it is, well, the location of the mean is different also, but is a problem with the skewed, or the shape of this distribution. It means that is, in this case, is a right skew. Could be a left skew going this way, right? So I have to understand that, these problems can happen and these different variations can happen, and I need to find out when I'm collecting a sample if that sample, has some kind of normal, only normal cause variation, or if there's a special cause variation that's happening. If my variation is too high, or if my variation is okay. If I'm mean center or not mean center, okay?